Alrighty, so we're going to start off with number 1 here on that worksheet that you were talking about. We're going to do both the front and the back. So first off, I've just kind of written down the problem here. This is our function. Now when it asks, is the average height increasing? When we think about increasing or decreasing, we want to think about slope, and the slope is represented by the derivative. So if we were just to take the derivative of this h of a function, then that will give us the slope at any point a that we plug in, and a represents the age. So I've taken the derivative. I think you by now kind of know how to do that. We're going to multiply by 2 and then subtract 1 from the exponent up there. So negative 0.0392 times 2, that's how I got this negative 0.0784. And then this a just comes from subtracting the 1 up there. And so we keep that a, and now we have, where does this 2.987 come from? That's just, we're taking the derivative and we drop the a there. So now we can just plug in the 2 different values that it gives us. We plug in 13 and we plug in 8 into the derivative, and that tells us, that'll give us the slope at those different points. So we get the slope at the different points, and now how do we decide what's increasing slower? Well, this is the smaller number here, meaning the slope is smaller, meaning it's increasing at a smaller rate than this larger slope here. So to answer the question, yes, the average height of a 13-year-old girl increases slower because this is a smaller number than that of an 8-year-old girl. Alright, moving on to number 2. Alrighty, so for number 2, I just kind of wrote down the derivative here because I'm pretty confident that you're able to find that, and I'll just kind of verbally go over it. We have 43,000. Excuse me, I'm missing a 0 here. There we go. So 43,000 over x, when we bring that x up to the top, we get a x to the negative 1. And then when we take the derivative, we have to multiply by that negative 1, and so that's where this negative sign comes from. And then we have to subtract the negative 1 by 1, and that's where this negative 2 comes from. And that 130 goes away, and that x that's attached to the 0.03 goes away, and we're just left with that 0.03. So the derivative is listed here, and I think you kind of know how we got there. Just be careful with this one. Remember, it's saying find the instantaneous rate of change, and that's the definition of what the derivative is. It's the slope or the instantaneous rate of change. Those are all the same thing. And now it's asking for the instantaneous rate of change for the average cost. So it gives you 2 different equations there, and you just need to realize, okay, that c with the little bar above it is the equation that I'm taking the derivative of, not that first equation. I think they just throw that first one in there to kind of trick you. Alright, so the answer there would be B. If you have any questions, let me know. We're going to move on to number 3. Alrighty, number 3 here. Just kind of wrote the problem down up top, and we're going to start taking the derivative here. This is going to be like our first step. The rest is just kind of simplifying. So when I am taking the derivative of a fraction with an x on the bottom and on the top, you're supposed to take, I guess the formula or whatever is supposed to be the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. And kind of an easier way that I say that is low d high minus high d low over low squared. That d just means derivative, and so when I say low d high, I mean the bottom times the derivative of the top, low d high minus high d low. And so I've kind of done that down here. I have low d high, the derivative of the top one, which, it's pretty easy to see how we got 6x squared, minus high d low. I take the derivative of the bottom now. Pretty easy to see how we get 20x cubed. And then that's all over the bottom squared right here. So this next step, I'm just simplifying. I multiply this 6x squared times both the 4 and the 5x to the 4th, and that's how I get the 30x to the 6th and the 24x squared. Okay, so multiplying both of those in, that's how I get both of these here. And then again, I just go ahead and multiply, the negative 2x cubed times this 20x cubed, and that's where I get this negative 40x to the 6th. And we're just keeping this denominator here because we haven't done anything to this. Now all I do is combine the like terms, so 30x to the 6th minus 40x to the 6th. That's where this negative 10x to the 6th comes in. And then we're just kind of keeping the 24x squared. Now, in your homework, it kind of has it in a different, the answer is kind of in a different, more simplified way, and that's because they bring out a 2x squared. So it leaves a 5x to the 4th minus 12, because we're bringing the 2x squared out. It's like factoring it out. And so that's how we get the answer D there. Let me know if you have any questions. Moving on to number 4. Alrighty, so we're just using the chain rule here. We're going to take the derivative, and we're going to kind of forget about that plus 10 out to the side, and that's just going to go away when we take the derivative, and that's because there's no x attached to it. So where does this negative 15 come from? Well, that comes from multiplying the 3 up in the exponent times the negative 5. So that's why I get negative 15. Then we just keep the inside there. This 2 just kind of comes from subtracting, by 1, that 3. And then this 5 out here is from taking the derivative of the inside function there. Alright, and so then I just simplify and I do 5 times negative 15, and that's how I get the negative 75. So just a pretty simple application of the chain rule. Let me know if you need further help or more explanation about the chain rule. But yeah, I think that's pretty straightforward, so that answer is going to be C. Alright, moving on to number 5. Alright, so to find the slope of the tangent line at a specific point, just remember the slope, or tangent line rather, the tangent line is the derivative, okay? And to find, that slope there, we're just going to plug in that value into the derivative. So first step, we need to find the derivative, of course. So I just kind of go ahead and I bring the 3 down, and that's where I get that 3, and then I subtract by 1, and so on and so forth, and then this 9x squared minus 4 just comes from taking the derivative of the inside here, and then moving to the next step, I just kind of, all I do really is just, simplify. Let's see. The 27x squared just comes from multiplying the 3. Since all of that whole first term is multiplied together, I'm distributing the 3 into the 9x squared minus 4 part. and that's why I get 27x squared minus 12, because that's 3 times 9 and 3 times negative 4. Alright, and then that 3x cubed minus 4x plus 1, all of that squared, that's just still hanging out. And now it asked for it at x equals 0, so I plug in 0, and these little arrows just show that term, when I plug in 0 for x, 0 squared is still going to be 0, and 27 times 0 is still going to be 0, so that whole term goes to 0, and really anything with an x in it is going to go and just become 0, because anything times 0 obviously is 0. Alright, so we end up with negative 12 here. We end up with a negative 12, and that's going to be multiplied by 1. 1 squared is just 1. And so that's how we get negative 12, and so the answer is going to be B. I tried to show as much work as I could there. But yeah, it's a pretty straightforward derivative. It's just hard to know what to do with the wording of the question. So remember, what's the slope of the tangent line at a certain point? Well, the tangent line is the derivative, so let's go ahead and find the derivative. And then to find the value of that slope at that certain point, we just plug that point in to our x, and that's how we get the value of the slope of the tangent line, which is the derivative, at that single point. Alright, moving on to 6. Alright, so number 6 is kind of funny, and number 7 I need some more time with. So number 6, I want you to check with your teacher. When you take the derivative of that function and then plug in 1, none of the the answers don't reflect what that is. So maybe it was just a typo on her part or something, but I'd like you to ask your teacher about number 6. And then number 7, just give me a little bit more time with. There's some funky kind of stuff going on with that. I have a feeling it's D, undefined, but give me some more time to kind of work that out. But you should have the rest of the problems done, and I've covered the rest of the problems, so I think you should be good to go from there. All right. Alright, so this is kind of, you're going to be using the product rule as well as the chain rule in this problem here. So for number 8, remember we kind of take the derivative of the first term times the second term, plus the derivative of the second term times the first term. So this 2 that's kind of hanging out front here, that just comes from taking the derivative of that 2x and then multiplying it times the second term. And then we're adding the derivative of the second one, the sine of 3x, times the 2x, okay? And so what I do is I do it kind of in one step here. The derivative of sine is cosine. Okay, so that's kind of like taking the derivative of the outside. So for the chain rule, it's almost as if, if you have something to an exponent, we bring that exponent down. Well, this is changing sine to cosine. And then we have to take the derivative of the inside, which is going to be just 3, and I'm multiplying that times 2x, and that's how I get this 6x. So that's why it's 6x times the cosine of 3x. Again, I just did the derivative of the inside times 2x. That's how I got that 6x. And then the derivative of like this outside part, which is cosine. So again, this is a product rule used with the chain rule. The product rule just says, derivative of the first times the second plus the derivative of the second times the first. And in order to get the derivative of that second term, we need to use the chain rule because it's not just sine of x, it's sine of 3x. So we need to take the derivative of the inside, etc. Just kind of reiterating what I said. Alright, let me know if you have any questions on that one. Moving on to number 9. Alright, so this can kind of seem confusing, but if you just write it out in the steps, it's not too bad. So you have this h of x equals f of g of x. This is what we call a composition of functions, you're putting this g of x function inside of this f function. Normally it'd be f of x, and so whatever you plug in for x, or whatever you have in that spot, you're going to plug in for x. Well, this time it's a function, g of x. So I wrote out here just kind of the, what the derivative of h would be. And it's literally just the chain rule. I'm taking the derivative of this outside here, and I'm multiplying it times the inside, and then I'm taking the derivative of the inside. Okay? So that's me just writing out, the rule, or, what the chain rule for that derivative would be. And now, it wants to know what happens when 4 is in that spot. Okay? So wherever you see an x, we're going to plug in a 4. And so I've done that in these different spots here. Okay? So what we do is now we look at that chart and we just start kind of plugging things in. So if you look at the chart, g prime of, and then you look up at the x's and go over to 4, and then you go back down to the g prime, it's going to be, g prime of 4 is 1. It says it right there in the chart. And then the regular g function of 4, well, it says what that is too, and that's 3. Okay? So now what is f prime of 3? And we just look at our chart, and that's 2. And 2 times 1 is, obviously just 2. So it's kind of confusing, but if you write out the steps, it's not so bad. So again, I just wrote out what the definition of the derivative would be. That's just using the chain rule. And then I went ahead, plugged in my number for x, and just looked at the chart and started filling things in. And slowly I was able to find the answer. If you have any questions, let me know. Moving on to number 10. Alright, so this problem can be kind of funky. Basically what I do is, for I think it's k there, it says like 1.2%, so I change that into the decimal form of a percent, and that's where this 0.012 comes from. So I just plug that in there, and it wants to know, when it's, when the population is going to be 10 billion. And so, we have, this is what the population is, so we plug in 10 billion right there. And then we have the rest of our information, so we just need to find this t. Okay? So I just kind of start solving. Everything in the blue here is my work to move on to the next step. So I started off with 10 billion equals 6.7 e to the 0.012 t, and then in the blue I say I'm going to divide by 6.7 to get it over to the other side, because I'm slowly trying to get this t by itself. So I go ahead and I divide over that 6.7, and once I do that, then I have to take the natural log, because now this 6.7 isn't over here, and it just has this e to the stuff. And in order to get that stuff out of the exponent and down, I have to take the natural log of both sides. Okay, so that's what I do here, is I take the natural log of that side, and then when I do it over here, the e goes away and this stuff comes down, and that's why I'm left with this here. And so then I go ahead and I just divide by 0.012. So I go ahead and divide both sides by 0.012, and then I'm left with just t over on this side, which is great. That's what we were trying to do. And now I have all this stuff here. And I went ahead and I plugged that into my calculator. I said the natural log of 10 billion divided by 6.7, or you can say 10 billion divided by 6.7, and whatever that number is, you take the natural log, or the ln, of that number. And once you get an answer for that, you're going to want to divide by 0.012. And now we have t over by itself, because we've kind of gotten rid of all the stuff that's attached to it, and we should have a a number value here after we kind of plug that stuff into our calculator. And so then we get this value here, t equals 1,760.311. So that's the amount of time that it's going to take to get to 10 billion population is 1,760 years or whatever. And that is with a growth rate of 1.2%. All right. I think I skipped number 6. I think there was just something funky that I wasn't sure about, so I'm going to go back and just kind of, go over that problem again, and I'll get you with an updated number 6 here probably tomorrow. Tomorrow being Tuesday. Okay. All right, well, I hope this helped, and let me know if you have any questions. Good luck with your homework.